Hey everyone, welcome back to the shop. Today we have a relatively simple lathe job to get done. We have this aluminum pulley that is off of a Harley Davidson, and the customer needs 185 thousandths removed from this face. So it's just going to be a simple facing job on this. All right, we're going to be using our 4-jaw chuck on the Precision Matthews lathe. We already got the 4-jaw loaded up. I've got it preset and we're ready to go. A couple things to note before we get started. We need to make sure that we don't push down on this flange right here. All right, we want to chuck in the center where the pulley is. So we're going to use some of our soft jaw padding. So we'll start with our copper pads. And we'll just set those on there like that. And those are not thick enough to be able to clear the flange. So I also have these aluminum pads there as well that we'll stack on top of that. And that will give you the clearance you need so the jaw can push down and not touch the flange. This is not going to take a lot of pressure to hold for a simple facing operation, so there's no worry about over chucking this and deforming the inside of the pulley there. And the copper will protect that aluminum shape on the inside from getting messed up. Also, the through bore of this pulley is large enough that we can use our 1-inch mic, so we'll be able to put that through there, measure the thickness of the hub. We'll jot that dimension down, subtract 185 thousandths, and that'll tell us what our finished dimension is that we're looking for as we're facing. All right, and then one last note. I've got these aluminum rated inserts from Walter that I'm gonna give a try. So we're gonna use this tool here and see how that does for our facing op. All right, so let's get over here on the lathe and get this job knocked out. Before we start in the lathe, let's go ahead and measure our pulley. Just going to put it in the vise here to hold it. Using our 0 to 1 inch Starrett mic. That's measuring 917 thousandths. Try it in a couple places and see if it's consistent. That looks good. 917. Try it down here on this side right here. 917. All right. Check it one more time. 917. So I'm just going to go ahead and write that down. 0.917. 0.917 minus 0.185. 0.732 minus 0.185 equals 0.732 inches. That's going to be our dimension that we're looking for. And we do have a slight tolerance there, so if it's, you know, a couple thousandths one way or the other, they said that's not going to hurt anything. But of course that is our target dimension that we're looking for. All right, so we'll go over to the lathe now, start getting her set up. Go ahead and give the 4 chuck jaws another wipe, make sure there's no dust on it. Same with the pulley face. I'm going to try to center it a little bit on those two if I can. All right, let's go ahead and move that one up. Take one of our pads, put in there. And then one of our aluminum pads on top of that. Chuck it very lightly. Go 180, do the same thing. Just like so. Snug them up, make sure it doesn't fall out of there. Got quite a bit of run out there, but that's okay. I'll get that indicated pretty easy. All right, so I'm going to use my favorite setup here. We've got our dial indicator. And then what I would like to use is my Starrett number 670 ID indicator attachment. My indicator is starting to stick there. I think, let me see if I can do a little cleaning on that. Just gonna put a little bit of this universal degreaser on here and see if we can clean this off some. That's doing better right there. Okay, that's a little bit better. I think I'm going to go with the, we're going to use the 670A. There's an A and a B. There's the A and the B. I've only used the B a couple times, and the bore on this thing is still a little bit tight. I think the 670A slides on there. Yeah, slides on there a little easier. So we're just going to roll with that right there. All right. I love this configuration because it puts the dial indicator in the orientation in which I like seeing it be in whatever I'm indicating in the lathe. I like my indicator to be in the position just like you see right there. All right, so let's see how far out we got. We got 1, 2, just over 200 thousandths that we need to move this. So that's going to be your high, and that's going to be your low side. We want to push the low side in. We want to back the high side out. So just small movements because you don't want your pads to fall out of there. You just do a little at a time and keep going 180. Let me make sure you guys can see this good. High, low. Within a couple right there, okay? Then once you start getting it close with, you know, a couple thou, right there is 1 thou. That's when you start snugging your highs. And you see that was kind of loose. So now really what you need to do is you need to go around and snug up all 4 of them so that they're all tight, not over tight, but just tight enough that you know it's not gonna come out of there and it's gonna hold it securely. And usually when you have just a couple of thou, you can continue to tighten your high as you need. In our case, tighten our low because we're doing the ID. Just the opposite when you're doing the OD. So right there, that's a 1/2 thousandths with a 1 thou resolution indicator, which is generally plenty good for this kind of work right here. We have less than a 1/2 thou movement. But next thing we need to do is go ahead and check our face. We'll go ahead and indicate this face and make sure that that's bump true. We may have to tap this a little bit against the chuck jaws, and then we'll come back and check our bore one more time. So we'll go ahead and remove our ID attachment from the indicator. And then we'll come in here and just put it on the face. Wow, 1/2 thousandths. We'll give it a try. That may be in the chuck, so I'm going to grab a soft blow hammer. That's the high, that's the low. So let's just give it a, I don't see any improvement there. High. No improvement, so we're just gonna leave it alone right where it's at. That could be in the machining of the part. It could be a half a thou out like that, but we are bumped up against our machine face on the back side of the pulley there. So we're gonna check it one more time, make sure that we didn't move it. Go back on with our ID attachment. Do the fine adjust. I like it at the 12 o'clock position because it's easier to see from my perspective here. Nothing. I mean, we're getting tense movement right there. So I'm going to check it one more time just to be sure. Just a very light amount of torque on these jaws just to make sure they're being held good. And I did move it. See that? I did. One of them was loose. Now we're back to half a thou. There we go. Literally no movement in the indicator. So we're going to leave it alone right there where it's at. Should be good to go. Oh, that almost came off. I'm glad I caught it there. And let's go ahead and give it a spin up just to see what it's looking like. That is 600 right there. Looks good to me. All right, let's start facing it off. I think we're ready to start making our cuts there. So I do have the lathe set at 9 thousandths feed rate. And again, we are using that insert from Walther designed for aluminum. So let's take a cut. We'll just start with like 25 thousandths and see what it's looking like, how it's going to perform. Running 600 RPM. I want to go ahead and get a 0 established. There's our touch off right there. You can see our half a thousandths out of trueness on the face. I'm going to go ahead and set, I've got this mag back indicator down here set to a 0. We're going to set our DRO to 0 right there. And let's go ahead and feed it in 25 thou. See how it looks. That performed nicely. Got a nice looking face there. 25 thousandths worked good. All we've got to take is a few passes at the same depth right there, and we're going to be at the finish in no time. Let me see if I can get you a better shot as we finish getting this faced off. Got a little bit of cutting oil that I'm brushing on the face here. Help lubricate that cut. 100 thousandths. We have 85 thousandths to go off of that. That should leave us 60 thousandths. I'm going to go ahead and get a measurement on it just to verify that. All right, let's see. I don't want to try to force it off there, so let's see what we got. 75, 89, 75, 85, 90, 1, 2, looks like 792, 92 and a half, somewhere in that range. All right. 792. I'm over here on the calculator. 0.792 minus 0.732 equals 60 thousandths. So we're right on the money. Let's keep it going. I'm just using some of my old school dark cutting oil for this. Always worked good on aluminum. Another 25, that should leave us 10 thousandths, so we'll make one finish pass on this. All right, if we're correct, we should have 10 thousandths to come off. So let's get in there and measure it. Get around here so I can read that micrometer. 25, 35, 40, 1, 2, 3. I'm getting 743 and we want 732. So that's looking good. It's a little bit under, just under that. So we'll take 10 thousandths and see where it finishes at. If we need to take a half a thou, we should be able to handle that too. All right, I'm looking at my dial indicator. We're moving in 10 thousandths, and up on the DRO it says 0.1846. Get a little oil on that face, a little on the insert. Let's see if we can make our finish pass. A little more stringy because you're not taking a very high depth of cut there. I'm just going to stop it right there without coming back across the face. And we'll go ahead and, so we're looking for 732 thousandths. Let's go ahead and see what we measure. Make sure it's squared up. Looks like I'm getting 732. 732 and about 6 or so. I think that's going to be close enough. We don't really need to take a half a thousandths on a pulley like this. So I'm happy with where it's at. We're going to leave it alone, and we'll change out our tool and come in here and chamfer this edge. Actually, we're going to chamfer both of these edges here. I want to measure that again and see if I can get you a better shot of this micrometer. and show you what we landed on. So 732, and I got to kind of reach over. Let's turn it like this and see. I can't see it very well. Let's see if I can slide it off the face without disrupting the mic. Keep you in focus there. Looks to me like it's lining up on the 5, which would be a half a thou. So I feel confident saying that we're at 0.7325, within a half a thousandths of the measurement that we were looking for. We got a carbide chamfering tool installed, so let's go ahead and break those edges. About a 10th thou edge break there. That looks nice. All right, one final detail. We need to deburr these holes. We're just going to use a simple Noga tool for that. Feel and make sure I didn't raise a burr doing that. I'll have to give this a wipe down, get our cutting oil off of it. But I think we are complete. That looks good. Nice job. The inserts did a good job on that. Okay, we just need to get it out of the lathe. Since we don't have to go back in there with it, we're just going to hold on to it. Get our pads removed. Move our chuck jaw. And I'm going to see if I can catch these guys here. I missed one. There we go. All right, guys. Well, I believe this job is complete. Everything turned out nice. Got a little bit of cutting oil still on there. But I'm happy with it. I think it turned out good. We landed right on the size that we were looking for there. And I'm sure they're going to be happy with it. There's another little bit of oil there. I didn't do a very good job of cleaning it, did I? But I was going to say this belongs to, well, it belongs to a customer at a local motorcycle shop, but it's a job that the shop is doing for someone, doing some custom mods. I don't know why they needed this faced off there, so I can't give you any more details on why they're modifying a stock pulley, but this is what they wanted, and this is what they're getting. So this job is done, and I wanted to go ahead and give you guys a mention, something that will be coming up very soon on the channel. So the mechanic that brings me these jobs for the motorcycle shop, he's a lifelong Harley Davidson mechanic, motorcycle mechanic, so he works on Japanese bikes, American bikes, he works on all of them. He has a Harley Davidson, and off the top of my head, I cannot remember the year or model. I believe it's a shovel head, pretty old, that he has been doing a custom build on, and he's told me, he says this is just a passion project for him that he wants to complete in his life, and he brought a couple parts to me that he wants to have modified for his bike. We're not talking about this. This one is a completely separate build, this job done right here. But I was going to show you because this is a job that's coming up on the channel. Tim is who this belongs to. This is his pulley right here. We are going to be machining a custom adapter plate that is going to adapt the same type of aluminum pulley off of a late model Harley. We're going to be adapting it to an older chain drive style of Harley Davidson. So we have a piece of aluminum that we're going to be machining into an adapter plate. We have to machine the pulley itself here to accept the adapter plate. And I believe there's going to be quite a bit of machine work involved with that. We're going to have some lathe work. We're going to have some mill work because there's hole patterns involved. And I think you guys are going to enjoy that project. And I know Tim, the mechanic, is very excited to have this job completed. Unfortunately, you know, he took this to another shop and he said it sat there in his floor for over a year after they said yes, they would do it. And then after a year, they called him and said, we don't want to do this job. Come and get this stuff out of our way. So Tim called me. We kind of lost touch there for quite a few years. And he was able to finally touch base with me again. Now he knows I'm here. He works right up the street at the motorcycle shop. And so I told him anytime he's got some custom projects to be done, customer base, personal base, whatever, let me know and bring it to me. And we'll help him get it done. So anyway, this is a job that's going to be coming up very soon. I'd like to try to get started on this. I know he's really excited to have this and get his Harley Davidson modified with a belt drive and do away with the old chain drive system. You can see this is the brake drum right there. All you motorcycle guys probably know all about this stuff, what we're looking at, what it's for, and all that. So anyway, some coming up projects that we're going to be doing on the channel. But anyway, this job is complete right here, and I hope you enjoyed. Again, I always try to be helpful and educational, a little bit entertaining there, if you will, and try to help all you guys out with this manual lathe work, the four-jaw lathe work, and you know, what it takes to get this kind of stuff done. A very simple job, and I imagine and there's probably a lot of people that are, you know, looked at this project and said, well, I would do it this way. Maybe you could put it in a mill. You certainly could. You could have clamped this down on the mill and used the mill to mill this off. You could put it in a CNC and get it done. But I like doing this kind of stuff in the lathe. That's what the machine is made for. That's what a four-jaw chuck is for. And we got it done, and it's on size, and I think they're going to be happy with it. So hope you enjoyed the video, and I hope you come back for the next project. All right, we'll see you then.